There we go. Patterns with prime numbers. All right, so this is what I'm going to tell you. All of the following numbers have exactly 3 factors. The numbers are 4, 9, 25, 49, 121, and 169. Once you finish writing that down, I want everyone to think about what do all of these numbers have in common other than the fact there are 3 factors. There's something that all of these have in common. I'll give you a couple minutes and I'll give you a hint. It is also possible to figure out what they have in common if you ignore the bigger ones. So if you look and try to figure out what 4, 9, 25, and 49 have in common, if you find a common rule, that will also apply to the bigger ones. So don't let the bigger ones discourage you from trying to find the rule. Are you guys ready for your hint? Okay, think about what multiplies together to give you each of these numbers. They're all squares. Perfect. I'm going to go ahead and try this. What? All right, they are all squares. So we know that 4 is equal to 2 squared. 9 is equal to 3 squared. 5 squared, 7 squared, 11 squared, and 13 squared. All right, so I'm going to rewrite that. Let me try to find a different color marker. I can do 2 different colors. All right, so this, we said is 2 squared, 3 squared, 5 squared, 7 squared, 11 squared, and 13 squared. All right, so I'm going to go ahead and erase this so we have more room. All right, so let's see, Lisa, we'll start with you. Can you tell me, and if you can't, that's okay. This is a kind of a different type of thinking activity. Think of this more as a practice in thinking using prime numbers. Do not think of this as like, okay, right or wrong, oh my gosh, this is like a concept I have to know right when she asks me. This is a pattern finding thinking project, okay? All right, so Lisa, or Mariah, I'll put you in pairs, how's that? Lisa and Mariah, working together, can you tell me, if we look just at 2, 3, 5, 7, 11, and 13, what do those numbers have in common? Okay.
I'm not gonna say they're all odd, but then the 2 is throwing me off.
Okay, so you're on the right track, but you're right, they're not all odd. Whenever we had the playing cards up there, does somebody know? Do you know, Rebecca?
Yeah, prime.
Okay, they're all prime. Thank you, that's good. They're all prime, all right? So, all the bases, the big number at the bottom is called the base, are prime numbers. All right, so now I'm gonna try to squeeze it in. Let's see. I'm gonna squeeze it in right here. All of the following numbers have 5 factors. And I'm gonna go ahead and factor these for you because I do, and you'll see why. 16, which is 2 to the 4th. 81, which is 3 to the 4th. 625, which is 5 to the 4th. 2,401, which is 7 to the 4th. All right, so as you can see, our bases here are also prime. So, as you can see, if we have a prime number squared, it has 3 factors. If we have a prime number to the 4th, it has 5 factors. So what if I told you I have some prime number and it is raised to the 6th power. Based on the pattern we have here and here, how many factors will this number have? Seven, right? It'll have 7. And the reason is, because see here our pattern is a prime to the 2nd power has 3 factors. So you take the power and you add 1. Okay? Here, a prime to the 4th power has 5 factors. Okay? So if we have a prime number to the 6th power, we just take the power, add 1. We know this has 7 factors. All right, so let me erase this and we're going to work some problems using this pattern. All right. Okay. We want to know what would be the smallest number with 7 factors. So this is something we talked about on Tuesday. So let me pick someone who was here on Tuesday. Tanya, do you remember what is the smallest prime? 2. Okay. And either Jayton, Dallas, or Chance, if we are wanting a number with 7 factors based on the pattern, we just looked at what power do I need to raise 2 to? 6. So the smallest number with 7 factors would be 2 to the 6th power. Okay, so if you want to know the number of factors, all you have to do is pick a prime and figure out what the exponent is. Now you must realize, of course, that not all numbers can be written in this form. You know, like 10 is 5 times 2. So this obviously doesn't work. But there are a lot of numbers that do. All right, so let's see. I can't calculate it out. Oh, I didn't. Bummer. I didn't calculate out what 2 to the, well, I can figure it out. 2, 4, okay. 2, 4, 8, 16, 32, 64, 128, 250, so 128, 64. 2, 4, 16, 32, 64. 64. There we go. I was a very nerdy child. I never counted sheep. I counted powers of 2. I just didn't realize that's what it was until I was in college. I would sit in bed at night and count like doubling the numbers. And then one time I was in computer science class learning binary, and they had us doing it. And I was like, oh, I already know that. So it was really, I felt like a huge nerd at that point. All right. Okay. So let's look at another question here. Will you please name 2 numbers not already given that have, or exactly, I need to put exactly, have exactly 3 factors. All right, so just to remind you, the ones that have already been used are 2, we've already used the primes 2, 3, 5, 7, 11, and 13. All right. So we've already used the numbers 4, 9, 25, 49, 121, and 169. So these are the off-limit numbers. If you would like to get out your phone and Google a list of prime numbers, you are welcome to. I do not expect you to have like a bazillion of them memorized. All right, okay, so let's see. Dallas, can you tell me, I need a number that has exactly 3 factors. What was the rule that we had? Remember at the very beginning, I said all of these numbers have 3 factors. So 4 was one of the numbers that has 3 factors. Okay? And we know 4 is written as 2 squared. So our rule was a prime raised to the 2nd power has 3 factors. So all I need is for you to give me a prime number and then tell me the square. You don't have to tell me what it is squared. You can't use none of those. So prime number bigger than 13. If you don't know, you can Google a list. That's fine. Oh, there you go.
214.
214? Well, 214 squared? Sorry, I was just a little surprised. Okay, so 214, that's not going to be a prime number. Here, this will make it way easier.
59.
259. Okay, I'm gonna actually pull up a list of primes, put it up here. I just realized that'd make it so much easier. Okay. List of. Here we go. Okay, so the prime numbers are the ones in yellow.
That's what I pulled up too.
All right, there we go. Much easier, hopefully. Okay. Prime numbers are the ones in yellow. All right, so which prime did you choose?
59. 59.
59, okay. So 59 squared, we know this has 3 factors. Okay. In case you guys wonder what the 3 factors are, they're going to be 1, 59, and then whatever 59 squared is. So these are your factors. All right, Jayden, give me another number that has exactly 3 factors. Okay, so 17 squared. You take a prime and you square it. So another number that has exactly 3 factors is 17 squared. Rebecca, since you have a calculator, could you tell me what 17 squared is?
289.
289. And can you tell me what 59 squared is?
3041. 30. No.
No.
3481.
Oh, 3481. Okay.
3481.
All right, and so the factors here are going to be 1, 17, and 2, 89. Is everyone comfortable with how to find any number that has 3, or not any number, but find a number that has exactly 3 factors? On your homework, what it'll look like is basically it'll say, take this rule and it'll extend it. And it'll say find numbers that have 6 factors, 7 factors, and so on. But this rule stays the same. All right, so let's look at another way to use primes. 225 is equal to 15 squared. Does 225 have exactly 3 factors? Huh? Okay, why would it be yes?
I'm gonna guess it's a prime, just looking at those, but I don't know.
Okay, so is it highlighted up here? Is 15 a prime?
Oh,
No, 15 is not a prime. Okay, so if 15 is not a prime, can we still say it has only 3 factors? According to the rule we figured out? No, right? 15 is not a prime, which means 225 can either have more factors or less factors. So, since 15 is not a prime, we cannot say with confidence it only has 3 factors. So the rule that we found only applies if our base is a prime. Okay. And the reason this is just like, this will not be on your next test. This is just an extra thing. If you're like, okay, well, why does it not work if they're not prime? Okay. The reason it doesn't work if they're not prime is because 15 is equal to 5 times 3. So that means if I replace 15 with 5 times 3, I use a rule of exponents and I apply this exponent to each of these. I get 5 squared times 3 squared. We know 5 squared can be rewritten as 5 times 5. 3 squared can be written as 3 times 3. Okay? And in order to find all the factors, so first, this is the prime factorization of 225, right? Because these, yes, Chance.
Is that the simplest form at the very top?
This up here?
Now the 5 times 3 parentheses, would that be considered the simplest form?
Okay, I'm not, simplest form.
Because on Hawks, they have I wrote it just like that down below it, and it's the simplest form. I guess similar problems do that.
Okay, it should be in simplest form. Take a screenshot of it and email it to me.
Okay.
That should be fine. Okay, so we have this. Okay, this is our prime factorization. But in order to find all of the factors, we have to combine these in every way possible. So I'm just going to start combining them. So we could just take the 5 away, because there's technically a 5, there's a 1 here as well. There's an understood 1. Okay, so I could have 5 times 1 is 5. I could have 5 times 5, 25. 5 times 3, 15. 3 times 3, 9. 3 times 1, 3. 5 times 3 times 3, 45, and so on. These are all factors of 225. So if for some reason you were ever helping your kid with their homework, or for some reason they decided to have a random math exam at work, and they said, okay, tell me all of the factors for this number, and you did not know them off the top of your head. If you could break it down into the prime factorization, then you could just do what I was doing. Just pick 2 of them, multiply them together. Pick 3 of them, multiply them all together. Okay? So as we can see, this obviously does not follow our rule. So if our base is not prime, our rule does not work. Okay. All right, so now I have one that I'm going to get an answer from each and every one of you, because there's a lot of different options. I want everyone to find a number raised to the second power, so squared, but does not follow the rule that it only has 3 factors, so like 225, but tell me how many factors it does have. Okay, so I'm going to write that up here on the board. So find a number that is squared that does not have exactly 3 factors, and figure out how many factors it actually does have. For y'all's sanity, I would pick the smaller ones. Pick the smaller numbers. All right. So everyone has to get one, so I'll let you guys go in order as you wish. So who wants to volunteer the number they came up with? Chance. You raised your hand and then you sighed like you didn't want me to go on you.
All right. Give me the question.
It's written right here. Okay, I need a number that is squared.
Okay, so I got 6. 6 squared is 36.
Okay, so where
I
you?
don't know how you do that.
Okay, 6 squared is 36. Okay, so that doesn't have exactly 3 factors. So tell me what the factors are for 36.
1, 2, 3, 4, 6, 9, 12, 18, 36.
All right, so we can definitely see for a number so small, such as 6 squared, there are a lot more than 3 factors. Are you, oh, I thought, are you clapping for yourself? It's okay. It's always good. I sometimes clap for myself, you know. When you teach math, some days that's the only applause you're gonna get. Let's be realistic. All right. Okay, Amanda, did you want to go next?
Oh, I didn't understand. So I did 4,
Mm-hmm.
but then I wrote, I think I was factoring. I broke it down more like.
Oh, instead of squaring it and then taking the factor. So you need to take 4 and square it. So we can still use that one. So here you are here. So 4 squared, which is 16. And I'm not going to write all the factors. I'm just, so we use all the factors of 16.
2
Mm-hmm.
and 8.
2 and 8.
4.
Mm-hmm. 4 and 4.
4
Mm-hmm.
and 8.
There's 2 more, but they're the ones that always trip people up because they seem too simple. What can 16 times what is 16? 1. So 1 is a factor. And 16. Yeah, so that one has 5 factors. All right, next volunteer. Lisa. 10 squared. Okay. Factors.
1, 2, 4, 5, 10, 20, 25, 50.
Okay, there we go. So definitely more than 3. All right, next person. Mariah, do you want to go?
I did 8 squared,
8 squared. Okay, here we go.
and I did 1, 2, 4, 8, 16.
Awesome. All right, we need Tanya, Dallas, Jayden, Taylor, Rebecca, and Rachel.
Let me know that I do this one.
Oh, somebody else gets it? Okay. Well, that's okay. Okay, you guys can repeat them.
Me, somebody that. I did 100. Oh, go ahead.
Okay, I'm sorry. What did you say? I didn't hear you.
I said a number someone else already did.
Oh, okay. That's fine. So you did 100?
Well, I did 10 squared.
You did 10 squared. Did any, let me say it this way. Did anyone pick a number that's not already up here? That's all we got? Okay. All right. Well, we're done then. We'll call it good. All right. So your homework, go ahead and get started on it here. You can work by yourself or with someone else. It's completely up to you. And of course, I'll help you if you need any help. You should have volunteered first. What can I say?